Hey everyone, it's Mark from Flight Sim School. We are kicking off our look at the PMDG 777 today, and before we get into learning how to fly it, I thought it might be nice to have a quick overview of the main systems that are 777 and when you'd use them. To be clear, this won't be an exhaustive list of what every button and switch does. What we're really focusing on here is what you'll need to know to be able to handle most situations with this plane. The 777 is a wide-body aircraft, and although the basic layout of the flight deck is similar to what you'd find in other Boeings, there are a lot of subtle differences that you start to notice if you pay attention, especially since this plane has a ton more automation than the 737. It all starts with these 6 displays that we see in front of us. They can be configured in a number of different ways depending on what your preference is and what's going on during your flight. The captain and first officer both have 2 displays in front of them, which in the 777 are officially referred to as the inboard and the outboard displays, but realistically, most of the time the outboard display on either side is going to be your PFD, where you can see your attitude indicator, the altitude, the airspeed, and so on. The inboard display can show a bunch of different screens with the knob that's just below it, but again, most of the time you're going to leave it on the nav display so that you can see where you are relative to your flight path. There's a lot of different information that you can show on the nav display itself, and you can control all of that with all the buttons and knobs that are just above. We're going to see how to use the map and distance modes in more detail once we're actually planning our flight, but below that, each of the buttons is effectively a different layer of information that you can show on the display, with the ones that you're going to use the most being the weather overlay that'll show you a very approximate version of the weather that's ahead of you, and the terrain radar, which you'll want to bring up any time that you're flying into or out of mountainous terrain. The other layers are going to show you different types of waypoints that are on the ground, from airports to nav aids and everything else in between, and you can even see information about restrictions that you need to follow on your route. Between the captain and the first officer, we have the EICAS display, and that shows you the most important engine details along with any alerts that you need to be aware of for your plane, and these can be either in white, yellow, or red to indicate how critical of an issue they are. Any messages that you see here will clear themselves automatically whenever the condition that triggered them resolves itself. So for example, when I start the engines, all of the warnings about the engines being shut down in yellow are going to disappear for me. If you want to clear the warning messages manually because they aren't relevant, you can press the cancel recall button over on the right, and that'll clear everything out for you. If you ever want to bring those messages back because maybe a message was appearing just as you were clearing it, you can press the recall button a second time and it'll all reappear for you, so you can just double check everything that's there. If we go back more towards the middle and we look just below the glare shield, that's where we've got the MCP that allows us to manipulate all of the different autopilot modes. And although it does share some similarities with the 737, there are some significant differences, and again, it'll just be easier to demonstrate all of this once we're in the air. Below the EICAS, we have a multifunction display that can show you the state of different systems of the plane, and that's operated by the buttons that are off to the right. The pages you use most frequently are the ones that are at the top there, so you'll have your stat page, which is where you can see your APU status, as well as the hydraulic fluid levels, and the engine page, which is especially useful at engine start, but it's also worth taking some time to explore all of the other pages so that you know what's on each of them in case you ever find yourself needing them. The buttons at the top here also allow you to customize where you display any of these pages. So if you wanted to display one of them on yours or the FO's inboard display, all you'd have to do is select the display that you wanted to show on first, then select the page that you want, and finally flip the inboard display to show the MFD page. Right next to the EICAS is where you'll find everything that you need for landing, from the basics with the gear and the auto brakes, but also the ground proximity section where you can suppress some of the different warning tones that you've likely already heard go off as you're coming in to land. The most commonly used one is the terrain override. It comes in really handy when you're flying into or out of mountainous terrain, since it can get pretty annoying and distracting if it's going off non-stop and all you hear is it telling you that there's terrain ahead. On either side of the MFD, we have two CDUs, one for the captain and another for the first officer, and this is where we would set everything up for our flight. And one nice thing about having two of them is that you can operate them independently, so in busy phases of flight you can multitask and have two different screens up at the same time to help you out. Below that, we have the throttle quadrant, and the main difference with the 737 here is that the stabilizer trim is a digital display that you control from the yoke instead, and the alternate trim that's right next to that is something that you should rarely, if ever, need to touch, so we won't go into any more detail about it. The speed brakes can be used to increase drag as we're descending, and they have a full range of motion through which you can extend them, and to make sure that they auto deploy on landing so that you can slow down a little bit faster, you'll want to make sure that it's set to the armed position before you touch down. The throttle and reversers are fairly straightforward, and if you're looking for the flaps extension speeds, they're actually up next to the auto brake switch just above. Below that, we have the controls for the radio, and again here we have frequencies on the captain's and on the first officer's side, so that allows you to plug in 4 different frequencies at any one time. So if you're flying on BATSIM or IVAO, you can set up all of the frequencies that you're going to need all the way up to cruise ahead of time, and you'll have them available at the click of a button to swap them in. From there, we've got a bunch more dials related to the radios, which for the most part you won't have to play with, and below that on the right side we also have the transponder, which when you're ready to go flying, you're going to want to make sure that you have it set to TARA. On the opposite side, we've got the controls for the weather radar, but because of the limitations of Flight Sim's weather implementation, tweaking these settings doesn't seem to change all that much of what you're going to see on the navigation display, so you likely won't need to use them. There's also what looks like a third CDU back here, but it's actually to operate the communications with the cabin, so if you want to simulate a cabin call, you can do all of that from here. Off to either side of the flight deck, you're going to find a tiller, which is what controls the nose wheel steering when we're on the ground. Since most of us don't have tillers though, you'll typically use your rudder pedals to steer the airplane, and when you do, it'll also move the tiller for you. PMDG has some recommended settings and sensitivities for using your rudder pedals as a tiller to make steering on the ground a little bit easier, and I find they work pretty well, so I'll link to them in the description for you, or you can just copy them off the screen. Next to that, again, we have on both sides a tablet, which is where we can import our flight plan, calculate our performance for takeoff and landing, as well as manipulate all of the ground ops, and we'll look at all of that as we set up the plane for our flight. As for the overhead, like with most airliners, there's a ton going on here, but most of these systems actually work automatically for us and they don't need our intervention unless of a failure, but it's still good to know where they are when we need them. The ADIRU is what provides the plane with your airspeed, altitude, and position over the ground information, and it's basically the equivalent of the IRS or the ADIRs that you might be used to on the 737 or the 320. Right below that, we have the asymmetric thrust compensation system, which defaults to auto, and if you end up in a situation where one engine is developing more power than the other or one engine fails entirely, it'll kick in automatically for you and apply rudder pedal input to keep you flying straight and level without you having to do anything about it. Below that, we have the electrical section with the battery, external power, and APU all available to provide you power depending on the situation. The battery is your first source of electrical power on the plane, and it's really just meant to power a minimum set of systems, and it won't run things like the air conditioning. If you have a ground power unit connected to the plane, which you can enable from the tablet, you'll see that the external power buttons here will say that they're available, and it's what you would typically use for the first part of your pre-flight flow since it'll power all of the flight deck systems. The APU, on the other hand, is basically a little engine that's all the way at the back of the airplane that gives you bleed air, and it makes starting the engines and running the air conditioning possible because of it. And once that's running, you don't need the ground power anymore. Right below that, we have the generators for all of those electrical sources, which are what provide power for all of the systems of the plane, and for the most part, this is all completely automated. At the top of the next column, we have the emergency exit lights guard, which should always be closed for flight, so those lights are always on, and the passenger oxygen switch, which is actually used to configure how the oxygen masks are configured in the cabin. And although you can turn it on, the mask won't actually deploy, but you will get an EICAS message saying that they're running. Below that, we have the window heat, which is one part of the anti-ice system, and these pretty much always stay on, so you can set it and forget it if they aren't already on. The 777 can detect when there are icing conditions and automatically turn the engine and wing anti-ice on and off automatically, so long as you have them in the auto position, so just double check it anytime that there's visible moisture and it's less than 10 Celsius out. Whenever the engine anti-ice is operational, you'll see the letters EAI appear in the N1 display of each engine just to tell you that it's detected ice and is doing its job. Back up near the top now, we have the button to deploy the ram air turbine, which is there to provide you with emergency electrical and hydraulic power, and you only ever need to use it as a means of last resort if you've somehow lost both your engines and the APU. The way that it works is it's literally a propeller that comes out of the underside of the plane, and the oncoming air spins it to provide power to it. And as I learned on one of my first flights with the 777, it is definitely fully modeled in flight sim. Below that, we have the hydraulics, which is what moves all the different control surfaces of the plane, from the gear to the horizontal stabilizer. And below that, we have a lot of switches for the interior panel lights, with the master brightness knob being the most useful one to know about when things start to get dark. All you need to remember is to press the button on the top of the master switch, and then turning it either left or right is going to override the illumination of all of the instrument panels in the plane that have a switch with a little dot next to them, like the ones that we see right next to it here. Moving to the next column of the overhead, the engine start switches are again simplified from what you might be familiar with the 737, and although the Rolls-Royce engines can start both engines at once, with the GE90s that we have here, you should still be starting them one at a time. Next up is the fuel jettison system, so if for whatever reason you need to head back to your departure point shortly after takeoff, but you're over your max landing weight, you can come here to jettison some of your fuel, and I might actually do a video specifically on this in the future because it sounds like a lot of fun. Below that are the fuel tanks. You can see that right now only the left forward tank is showing as if it has fuel, and that's because the APU is pulling from it to keep itself running. And then as you're getting ready to start the engines, you'd come back here and turn all of the tanks to the on position. In the top right, we have the air conditioning system, which for the most part you won't have to play with since it's all set to auto. Although if you're close to your max takeoff weight on a short runway, one way that you can get more power from the engines is to turn the packs off. That's going to reduce the need for bleed air from the engines, but don't forget to turn it back on once you're in the air, otherwise your passengers are going to start to roast in the cabin. The bleed air is what provides pressure for the cabin by supplying air to the environmental systems, and it's also used by the wing and engine anti-ice to keep everything running nicely in icing conditions. The pressurization system is what keeps your passengers and the flight deck crew from suffering from hypoxia, and in normal operations you won't have to interact with it very much. However, if you happen to tail strike, ask me how I know, you'll need to use the outflow valves to depressurize the plane and repair it from the CDU. All the external lights which we're going to interact with are down at the bottom for easy access. I'll usually turn the landing lights and the strobes on when I join onto a runway, and then I'll turn the landing lights off as I go through 10,000 feet, and then do the opposite on the way down and turn them on at that point. Another little thing to note here is that there is a click spot right above the landing lights that'll toggle all of them on or off with a single click of the button, so it's a nice little shortcut to know about. I always turn the taxi and runway turnoff lights on together for taxiing to and from the gate because they give you just that little bit more lighting, and I'll turn the nav lights on as I'm ready to push, and then the beacon as I'm about to start the engines. The logo light is really something that's up to you if you want to turn it on or off to illuminate your tail, and the wing lights are typically only used for checking ice on the leading edge of the wing, although they do give a really nice effect when you're flying in the dark, so I tend to turn them on just to make it look better. From a maintenance point of view, there are two places that you should be aware of if you experience problems or failures with the airplane and you need to restore it into working order. The first of those is in the CDU. So if we go into the PMDG setup menu and then we go into aircraft, failures, and then all systems, we're going to have a couple of different options here. If you don't want to worry about failures based on wear and tear that the airplane experiences from flight to flight, you can disable it here, but really you're removing a part of the experience of this plane by doing that, and it's not like it's something that happens very frequently either. If you broke something with the plane, for example, like that tail strike we were just talking about, by going into the maintenance page, you can clear all of the failures from the system as well. And you can also service all of the components of the plane from here, although some of this can also be done from the EFB. So from here, if we go into the ground ops app and then onto the maintenance tab, you can hover over any of the components that are shown here to see its current state on the plane diagram, and it'll either be in blue, yellow, or red just to indicate what their current state is. And then if there is an issue with it, you can just press the button to repair it as well. That's going to wrap up our quick overview of the flight deck systems, and in the next video we're going to learn all about how to prepare for a flight. So make sure that you've liked the video and subscribe so you don't miss out on that one, because we're going to go into all of the details of route planning.